you it's relevant to the topic I do want to discuss. For anyone who is not familiar with mutation testing, let me just give you a brief introduction of what it's about and how it kind of works. Here's some documentation, and as you can see, the name is fairly descriptive. What a mutation testing framework does is it will make small changes to your code, then run your unit tests and record what happens. The general argument here is that traditional code coverage really only lets you know that a line ran. In this case, you'll see that it went over your condition that the age had to be greater than 18. Or greater than or equal to 18. However, it doesn't actually test that the line did what you wanted, just that it ran. As you can see in this example here, you don't actually have a test that the age can't be under 18 or that the age can't be exactly 18. So it's kind of made it apparent that you're missing some test cases that might be very important for your workflow. Mutation testing tends to engender strong feelings either for or against it. Critics will point out mutation testing is slow, and some languages are prone to hard-to-test constructs or side effects. For example, if you think about event handling and propagation interactions between multiple components in JavaScript, especially across different browsers, you can get into some very weird situations that are cumbersome at the least to try and instrument and test properly. This can also lead to code bases that are slower and harder to refactor as the code and tests become very tightly coupled and you start moving into patterns that are really designed around the injection of mocks or other test easing sort of designs. Despite all these criticisms, I still think there's some value in using mutation testing occasionally as a tool in your toolbox. If only to learn another way to think about the code you're writing. It kind of makes you conscious of how hard will it be to test. Is this line of code I'm about to write valuable enough that it warrants a test? Is it just me making an assumption about the behavior of what I think the code should do? It also can be useful if you're new to a language to help learn about some of the nuanced details or idioms of the language. Mutation testing is good at spotting things. For example, like the differences in behavior between equality tests that seems to crop up differently in every language. Mutation testing can make it obvious if a comparison you think you're making isn't behaving the way you want it to. So I tend to take more of a middle-of-the-road approach to mutation testing. I certainly don't want it running every time, and I don't want it holding up builds on 100% passing. But I do see where people like it and where they can get some value from it. Now, on the other hand, I think the reversed concept is much easier to argue for. If you delete or change lines in your tests, barring the assertions, I think it should result in your tests failing. It's super common when writing tests that we copy and paste everywhere, or we may not think about what the minimal amount of scaffolding is that we actually need to get our tests to pass. When I want to know how to work with a new piece of code, the first thing I like to do is I go and look at the unit tests, and I see how the authors intended you to interact with it. If the unit tests have unnecessary settings or are doing a lot of legwork that isn't actually useful, I'm going to end up using that same cruft in my actual code. This dead test code makes for more noise, it's harder to read and understand your tests, and more importantly, it can hide false assumptions that you've made. Let me provide an example. I have a side project where I work with Django and Python, neither of which I'm overly familiar with. I needed to add integration tests as the code base was untested, and Googling quickly led me to find code samples, like this one I've included here, as the way to test a class-based Django view. Django is a model view controller framework for running a web server in Python. And it wasn't until I was wrapping up my new endpoints and I'd written all my tests that I kind of got worried, because I'd managed to write all these tests without ever messing up one of my URLs. That seemed unlikely to me. I hadn't paid a lot of attention to it, and you very rarely ever get something right like that until you're very experienced. So I quickly entered gibberish for one of the URLs and watched as all of my tests sailed along and passed green again. Looking closer, you can see that we're specifying the view we want in two places in the provided test sample. The factory where we provide the string for the URL, and the asView call, which is called in the actual class under test, in this case, a resolve auction class. And so what was happening is it basically throws away anything the factory sends along and just assumes that you're going to, what it calls asView, it's calling it on the resolve auction. This led me to dive into the Django documentation further, and after poking around and reading through, I eventually came up with a second approach, which does much more what I want. The URL I specify in the factory post matters and is used to resolve the view programmatically later. So I had a little more faith that the new endpoints I was going to roll out actually existed and would be where I thought they were. So as you can see, you may see that you think you're testing a situation or that your code is properly handling some input, when in reality nothing of the sort is actually happening. Some of these problems can be avoided with TDD practices, and specifically the concept of making sure that your tests can fail. But I still like thinking about it from a mutation perspective. If I can change this part of my test without breaking the test, why is it here? The best defense for this why is it here argument is usually that it's part of a more realistic usage of the code under test, and I don't want to repeat a large set of assertions each time I write it. I've started trying to push back on myself when I make that argument, and suggesting either that I should be paring down the setup code when it's not used to keep things cleaner, or I should really be building assertion helpers that make it easier to repeatedly test the state cleanly without a lot of work on the developer writing tests. Another thing is I'll often catch myself not writing these assertions because, well, I have other tests that already will catch that. I don't need to worry about catching it in this new test I just wrote. And that's often true, but is generally a sign that I'm avoiding making the improvements to the test that I really should be. You don't want to be in the situation that you rely on one specific test for a large chunk of your functionality being verified, when another developer can come in and change or remove that one test, not knowing that they're removing the entire safety net for all of the code under test here. So I hope this provided some food for thought for you and gives you a healthy curiosity for the topic of mutation testing. I think maybe next hackathon weekend, someone needs to think about whether it's time for mutation testing for tests. But barring that, I like the mental state it puts me in when I'm looking at my tests and I'm stopping and asking, is this code actually useful here, or am I just going to be confusing a future developer who has to come in and work on these tests or on the code that these tests support? Thank you, and have a good day.